Fluoroscopy, also known as fluoro, is the real-time imaging of internal structures or functions. These real-time images are called dynamic studies. Thomas Edison invented fluoroscopy in 1896. The X-ray tube is usually hidden under the patient within the table. The image receptor is housed above the patient. As you move the image receptor, the tube underneath will move to stay aligned. There's no need to worry about detinting. Although fluoroscopy was designed to be dynamic, it can take static images, or what we call spot films. On average, the MA is set to 5. Brightness is dependent on the anatomy being imaged, KV, and MA. A high KV and low MA are preferred due to the considerable increase in patient dose because of the continuous exposure. Above the patient is the image intensifier. The image intensifier is a special piece of equipment that uses sorcery to convert X-rays into an image. Let's see how the sorcery works. Just kidding. There are 6 main components to the image intensifier. First, the whole image intensifier is about 9 inches long and is encased in glass. Within the glass, voltage can reach up to 25,000. Second, the input phosphor acts as a scintillation layer, which converts X-rays into light. 3, just like in our X-ray tubes, there's a cathode side and an anode side. Here, the photocathode layer acts as a photodiode and converts light into electrons. 4, the anode is a circular plate with a hole in the middle. Electrons will pass through this hole and hit the output phosphor. 5, the output phosphor converts those electrons emitted from the photodiode back into light. It also produces 50 to 70 times more light photons than the input phosphor, generating a total brightness gain of 5,000 to 30,000. Finally, there are electrostatic focusing lenses which guide and intensify the electrons from the cathode to the anode. When X-rays hit the input phosphor, they get converted into light. Then, the light hits the photocathode and gets converted into electrons. Those electrons are then accelerated to the output phosphor, where the electrons are then converted back into light and sent to the computer to produce an image. Where the electrons cross over is called the focal spot. Knowing the focal spot will be important later. A multi-field image intensifier allows you to magnify an image. Magnification can be accomplished by changing the size of the input phosphor. Input phosphors usually come in 12, 17, and 25 centimeter sizes. Let's see what happens when we go from a 25 centimeter input phosphor to a 17 centimeter input phosphor. Now watch it again, but this time focus on the focal spot. The focal spot is closer to the output phosphor when we're using a larger field of view versus when we magnify, that focal spot is going to get further away from the output phosphor. When we go from a 25 centimeter to a 17 centimeter, we increase the voltage across the intensifier. Increasing voltage reduces the field of view and magnifies the image. However, a magnified image will be a dimmer image, so we need to increase the EMA to compensate. The patient will receive over 2 times the dose when the image is in magnification mode. Luckily, many modern-day fluoro machines use automatic exposure systems and automatic brightness controls. It is always best practice to be aware of your technique and how long the patient is being exposed. Digital fluoroscopy is similar to conventional fluoroscopy Except digital fluoro uses the tube like in normal radiography. Instead of conventional fluoro's 5 mA, digital fluoro uses mA in the hundreds. Dose to the patient is reduced, however, because the tube pulses radiation instead of a constant stream. Digital fluoro machines can reduce patient dose by about 50%. The image receptors used in digital fluoro are similar to the image receptors used in digital radiography. They're either thin flat panel or charge coupled device.